Good evening, everyone. Fantastic to have you all here tonight as we explore areas of evidence-informed science practice. This to me is probably the most exciting webinar I've given so far, apart from amazing registration numbers, and we've got people coming in from every state and territory. So please pop down where you're from and what your role is into the chat box so we can all know where you're coming in from tonight. It's combining two of my very favorite things. I was a scientist before becoming a teacher, so fantastic to talk about science, and I was a science teacher, still am a science teacher to this day. Thanks for joining us, Catherine, great to have you here. Thanks everyone. Keep on chatting in the chat box, we'll keep that going throughout the night, but let's make a start because I value your precious time as teachers, teaching assistants I know we've got on the line, and as leaders and also as policymakers. So we've got a whole range of audiences here tonight. So start off by really acknowledging that we're standing, and I myself are standing on the lands of the Wurundjeri people of the Kulin Nation, and pay my respects to elders past, present and emerging. I know that we're meeting from lands from all over Australia, which you're going to be typing into the chat box soon. So please share with us where you're coming in from. And we pay our respects to elders past, present and emerging from all the lands that we're meeting on today. Can I just get a hands up that everyone can hear me nice and loud and clear tonight? Beautiful, thank you. What excellent hand raising. Thanks a lot. All right, let's jump straight in. So we're going to be covering up on briefly touching on the 7 recommendations for teaching science. These are all evidence-informed recommendations coming from our partner organisation, the Education Endowment Foundation. And on every slide, I'll have a link down the bottom that takes you to the relevant resource that I'm drawing from. So we'll be starting off by talking about preconceptions, and then really important aspects, and one of my favourite topics is self-regulation and metacognition. We'll then be talking about the extremely useful way that we can use models in science to help our students understand important concepts. And then we'll be talking about memory, and there are various different little things that we can learn about our students, the way our students store memories, and also the way that we can help and stop them from having cognitive overload. Then we'll be delving into practical work, which I love, and the language of science. And then feedback. So we've got a lot to get through. We're going to touch on them briefly, and I'll be looking for you to interact throughout. But it really wouldn't be an evidence for learning webinar if we didn't start with an open poll. Oh, fantastic. So we're getting a lot of different states and territories joining us. Thanks everyone for chatting it into putting it into the chat box there. So the quiz should come up for you. And you put your hands up if you can see the quiz. Yeah, beautiful. Okay, great. Start popping in your answers. Oh, you're already voting. Fantastic. So we've got 3 questions tonight, and I'll pop them up on the slide as well so we can follow on with that. And so we're saying feedback on how students complete a task is more effective than general praise is our first question. Our answers are coming in there. Metacognition and self-regulation cannot be taught is our second statement. Rather, it is found within the innate ability of the student. So the leading sentence is, the current evidence base suggests that. And then we have feedback for students is most effective when targeted to select the most effective. They're actually ranked from most effective to least effective. So pick the one that has the most effective through to the least effective. Oh, we're getting lots of votes in. I'm about to close it. The vast majority of you have, a lot of you have voted. I'll give you, say, 30 more seconds while I find out. Oh, we've got someone from Melbourne as well. Hi, Wendy. Great to have you here. Great. New South Wales, South Australia. Keep popping in where you're from. It's really interesting to know. Great. We're going to end the polling now and have a look. Let's have a look. Fantastic. Well, for the first one, Sunshine Coast, oh, awesome. For the first one, so feedback on how students complete a task is more effective than general praise. You all were yes, that is certainly true, Dr. Vaughan, I can hear you saying, so that's fantastic. Then all of you have come back with false as well for the one that I threw in, which is metacognition and self-regulation cannot be taught. It can indeed be taught and is taught. So that's fantastic. And now the next one, which is the tricky one, which I was asking if feedback for students is most effective when targeted to, and it was meant to be ranked from most effective to least effective, and ranking it most effective to least effective, yes, we've got the majority, 53% have come back and said it is self-regulation, process, task, and then self as last. Yay, you're also doing so well for a Tuesday night, quite far into term really. So that's great. And we'll be breaking that down specifically what that looks like in a science classroom tonight. So let's move on into the exciting content. Also, we have the Associate Director from SVA, from E4L, joining us, who is in charge of running all the Learning Impact Funds. Dr. Pauline Ho, she's joining us on the chat box tonight. So she'll be answering your questions and also shuffling and sending them to me as well. Oh, ACT as well. I was just there. I was in ACT on Thursday and Friday. Fantastic. Okay. All right. So here are some of the key ideas around those 7 recommendations. So we've got to really recognize that students will already come in with certain ideas to lessons. So that's dealing with their preconceptions. Self-regulation, helping them direct their own learning. Modeling, helping students to retrieve and retain knowledge. Practical work, how do we use it purposely? And then the language of science, the beautiful specific vocabulary that we can teach our students, and also feedback and its key purposes. All right, let's dive into this a bit more. Great. So helping our students, and really within the classrooms, inducing cognitive conflict is an effective way of moving our students' thinking on and helping them reconstruct their effective ideas. So sometimes these misconceptions can be quite difficult to shift, but in doing so can lead to big gains in learning, and particularly for threshold concepts, which we'll be going through exactly what those are in a second. So diagnostic questions and small group discussions can be a great way to identifying misconceptions. And I'm sure a lot of you are doing these in your classroom right now. It's important to revisit these key ideas and challenge these conceptions multiple times so that we give our students a chance to develop their thinking. So if we have a look, here's an example here of, and I'll get you to type into the chat box if you want to, which one you think is the right answer. But this is a question that you can use as a diagnostic question So it will help you identify if your students have a common misconception. And the common misconception here is that some living parts of organisms are not made of cells. So if a student answers anything other than C, yeah, C, excellent. If the student answers anything other than C, we know that they think that cells, that different parts of organisms are not made from cells. So we've identified that that misconception exists, and we can work with them to get them to move past that idea. Other ways that we can do this is through dialogue, asking students at the start of the topic to discuss what they know about the topic. And students' ideas can be kept throughout the topic and revisited throughout to show how much they have grown in their learning throughout. All right, so this is an example of a way that we could help our students in thinking about solids, liquids and gases. So sometimes students have the misconception that a gas has as many molecules within it as a liquid and a solid. But we can take them through this by, for example, showing them with a syringe and pressing down on that syringe and showing that it can be pressed. But while a liquid and a solid, we can't do that for, we can demonstrate that. So demonstrations can be really useful in helping us get past misconceptions. So I was talking at the beginning about threshold concepts. Threshold concepts are magnificent because they're transformative, so they result in a change of perspective around the subject and might involve a shift in attitudes and values. They're irreversible, which is lovely really when our students are learning and we put so much effort into their learning. So the resulting change is unlikely to be forgotten. They're integrative. They expose previously hidden interrelatedness between other concepts within a discipline. And they can be troublesome. They can be difficult for students to embrace because of their vast nature. So an example of a threshold concept for all those biology teachers out there. And is anyone a biology teacher? Pop it into the chat bar so I can see that now. An example of that in biology is evolution. All right, great. So we've had a quick look at misconceptions. Now we're going to have a look through metacognition and self-regulation. You can see it here, the high-level details from our teaching and learning toolkit, which we have up on our site. What I would like you to do now is to put into the chat, yeah, the concept of the Big Bang, lovely. Biology teacher, yay, primary teachers as well, fantastic, great to have you all here. I'd love you to pop into the chat box how you would define metacognition and self-regulation, and if you think they're helpful skills for students to have. I know that the people that did respond to the survey said that you would definitely thought that they could be taught, which is fantastic because they definitely can. We'll be going through how to. Great. Now, is anyone brave enough to type something into the chat box around self-regulation and metacognition, knowing that there are no wrong answers? Eh, lovely. Thank you. Thank you. Monitoring your own thinking. Lovely. Monitoring your own thinking. Thinking about thinking. Yes, beautiful. Definitely positive. Thank you very much. Lovely. Metacognition is being able to talk about your thinking, and self-regulation is about your learning behaviour. Lovely. About students analysing their thinking. Self-regulation is about students monitoring their work and achievement. Thank you all for your generosity and sharing your definitions tonight. That's fantastic. I once heard Sir Kevin Collins, who is the CEO of our sister organisation in the UK, And he's a sir, as in he's been knighted in education, and he described it as getting a helicopter and flying above the learning and seeing the peaks and the troughs. So I'll steal that from him tonight, but we're going to go into it in quite a bit of detail now. So 3 aspects in self-regulation. And we have our cognition. So this is about the students really thinking about what strategies that they can use to learn. And these will be subject-specific strategies. So for example, strategies for solving equations, or I remember my delightful days in chemistry, or planning for controlled experiments. And then we've got metacognition. This is another element. And this is where they monitor and purposely direct their own learning. Like you were saying, it's checking that they're using the right strategy for the task that they're undertaking. And then motivation, which we all know what that is. That's students really being able to put, in the words of, I think, Stephen Covey, put first things first and really delay gratification and do what they need to do. So in this one, we've used the example of a student motivating themselves to understand, to undertake tricky tasks for homework or revision so that they will learn it. Great, so that is our beginning definition there. In metacognitive knowledge, there are 3 aspects, and bear with me, this is quite heavy right now. I think we're going to feel a bit of cognitive load on ourselves tonight. So metacognitive knowledge is knowledge about how we learn, our own abilities and our own attitudes, all right? Very important. Then we've got our knowledge of strategies, what's effective and what's available. And that's going to be different for every single task that is set in science. Then we've got knowledge of the task. So that would be specific if they've done this particular experiment before, say a titration, they'll know the steps that are involved. And then the next time they do it, they should be able to apply the strategies that they've learned to that task. I remember my first titration, I was so excited. I'm getting overly excited tonight about titrations. And I found out that there was a titration competition too. I never got to go in it, but I was just excited that there was one. All right, and metacognitive regulation, that's thinking about how we're undertaking the task. And this is a diagram that sums it all up, all right? Now, what I'll do is walk you through an example of how we can do this in practice, because that's really what we try and be all about here at Evidence Learning, is that that's the theory, and then what does it look like for yourself as educators? So one thing to always remember really is, as a teacher, if you're explicitly showing your students how you think, well, then you're letting them in on your metacognitive strategies. You do this by working through problems verbally in the class, talking through how you're approaching the problem and the kinds of strategies you're trying and why you've chosen them and how you're also monitoring them. With this next slide here, I like this because it shows the different phases involved in a student plan monitoring and evaluating their learning. And there are specific questions that we can ask at specific stages within this. So, for example, in the planning stage, are there strategies I've used before that might be useful? How can I ensure I only change one variable or one factor at a time? That's a beautiful question. And then within the monitoring phase, are the strategies I've chosen working? Am I really only changing one thing at a time? So constantly displaying to the students these types of strategies. And then at the end saying what worked well, what didn't do well, what could I have done differently next time I have to plan an experiment. So I just like that as an overall scaffold for your thinking. within the classroom. So modelling. Models are a great way to support understanding. They've been around for a really long time, as long as there have been scientists trying to explain things to each other. I would use a lot of them always within my science classroom. I always loved a diagram. It's really the idea that a picture speaks 1,000 words. So what this one here is showing is the barrel analogy, and that explains the fact that there are limiting nutrients on plant growth, and the height of the water represents the plant growth, and each of the wooden staves represents one of the nutrients that plants need to grow. So for this example, plant growth is limited by potassium. So by using models, visual, and now we'll go through all the different types of models that we can use, can be a really useful way for our students getting around some of the tricky concepts in science. But they're not tricky, they're just beautiful concepts, really, aren't they? Three-dimensional models, plastic, stick and ball, a model of organic molecules, verbal and written models, using analogies, mathematical models, beautiful chemical formulae, visuals, graphs, diagrams, animations, and computer models as well. So lots of different models that we can use to help our students learn. Fantastic. All right, now we're jumping to memory. And so we're probably feeling our memory right now. What we've got is a few definitions at the front, so which I'm sure you're all familiar with, but we can always use a refresh just to keep our cognitive load not from overflowing. So long-term memory is our store of knowledge, while our working memory is information that's being actively processed. It's where the thinking happens. So I can hold around 7 bits of information and only keeps it for about 20 seconds unless it's refreshed by rehearsal, in pulling that out again and then practicing that again. So any task for our students that exceeds the limit of working memory will result in cognitive overload. And that's what we're not aiming for tonight. This increases the possibility that the content may be misunderstood and not effectively encoded. And remind me that I'll send through, there's another piece too from Ceci, a lovely piece on cognitive load, if you want to read more about that. All right, a key way of preventing cognitive overload is to make sure that students commit important information and frequently used information to their long-term memory. So how do we actually do that? So different ways that we can do that is a spaced review. So that means we go back to a topic. We can write these into our lesson plans and into our unit plans after a forgetting gap. And that's going to strengthen the long-term memory. So a simple way to do this is to always build review time into lessons, and from the previous lesson or at the start of the next one, or over longer periods at the end of each week, month, or topic. Retrieval practice involves retrieving something you've learned in the past and bringing it back to mind. And now we're going to have a look at a simple way that we can reduce split attention, which is something that can lead to cognitive load with our students if they have to refer to multiple sources to complete a task. All right, so have a look at this diagram here, and you guys let me know, what one do you think is easier to understand? The one, diagram A or diagram B? A, yeah, A. And what, yeah, exactly, you guys can see it straight away. And this is a simple one. I guess it's not simple in that you might have to change some diagrams, but it's a simple tip in that we can simply reduce cognitive load by just making sure that there's no split attention within our diagrams, by ensuring that the labels are actually on top of the areas rather than having a key say in biology. Yep, everyone's got it. A is easier. You're all feeling that that is easier. Great. All right. Practical work. So practical work to me is everything in science, probably because I was a scientist for 12 years prior to coming into education, and that's what scientists do. They do experiments. So, but why do we have it in education? Why do we have it within our classrooms? We're teaching the principles of scientific inquiry, and the beauty of the principles of scientific inquiry is that they can be applied to problem solving in area of life. So you're actually teaching your students how to problem solve for the rest of their lives, which is an amazing gift to give someone. All right, we're also improving understanding of theory through practical experience. We all know that when we see something ourselves, or we touch it, or we feel it, we know that that will make more of a memory for us than just being taught it. All right, we're teaching specific practical skills such as measurement and observation that may be useful in future study and employment. I think they definitely are. Higher levels of skills in communication, teamwork, and perseverance. And no doubt we've all experienced those before. And to motivate and engage our students, I would say as much as possible, make every lesson a practical lesson as much as possible. Even with DNA, you can do that. Anyway, getting off track, but kind of on track as well. So use a part of learning sequence. I'm sure that's what you're doing right now, and sort of think about the progression that you need to build in your student skills over time. So if you're in the primary setting, you'll be starting with some basic experiments, teaching the students basic observation skills. While if you're in the secondary setting, you'll be getting to complex equations and complex experiments that they'll love. They'll love them at every level. So it's the same thing as planning your unit. It's the same practical steps you need to really think about in developing their practical skills. So we talk about it being both minds-on and hands-on. And that was really my experience in being a scientist. So I find this very authentic. So if a practical activity is hands-on, do the students do what was attended? So the students have done what's attended with the objects and materials provided, and they make the intended observations. Now the step the mind's on is they think about what they're doing and observing using the ideas and intended in the activity. So activating them and making sure that when they're adding the different substances, for example, they know exactly what is going to happen and why that's happening. And then if we look at the column of do the students learn what's intended, well, can they later recall and describe what they did in the activity and what they actually observed? And if their minds are on, they can discuss it. They can talk about the ideas involved in it. So within this, there are different ways to approach practical science. I've seen some lovely virtual experiments in some schools in southwestern Sydney at the primary school level. John Go's school there, call out to him, doing some excellent work with virtual experience where they were changing different variables and looking at the growth of plants in the accelerated setting, which was useful in that primary setting. And sometimes if you have limited resources, virtual experiments can be really fantastic to support your students. Open-ended projects are fantastic. because what they allow your students to do, and I was lucky that the curriculum where I was teaching supported that. So we had extended experimental investigations, and they would go for 6 weeks at least, and the students were able to choose whatever topic they liked, and boy, did their skills develop through that. I mean, it was amazing to see their engagement levels were just through the roof when they were running, when they were designing, running. This is at year 11 and 12 stage, designing, running and executing their own experiments and then writing up those results. So I really encourage you, if at all possible, have open-ended experiments where the students get to determine their topic and support them in that, because I think if they've got a genuine interest in that, that can really drive engagement and curiosity, which are fundamental to, I think, lifelong love of science. So now moving it to talking about the specific words around science. So a lot of content, high vocabulary demands in different scientific streams. So really make a conscious choice about what words you can, you're going to explicitly teach and when to introduce them. And focus in on as few words as possible in the beginning, so that making sure that the students have those memories in those words in their long-term memory, and that they're able to access them quickly and easily in order to feel like they're being successful in science. So really less is more initially. A deep understanding of fewer words is better than understanding a lot of words at surface level. For those students that want more, they can be easily extended by providing them with different types of scientific literature. I've had students engage with scientific papers, and those that did loved it. Then others, I was helping them really just to get across those key words that they needed to know in order to do a good job in the subject. So, and this is valid for both the primary and the secondary setting, and it can be incredibly helpful in subjects such as biology, but across all subjects as well, which is really helping students to understand the meaning of the root words and how to use prefixes and suffixes to change the meaning of words. And we've got here photosynthesis as an example of that, in looking at the different morphemes, which are the unit bits of each of those words, and how they break down and what they mean. Because if they can, oh, thank you. I'm glad, it's a very powerful strategy. Thank you for that. Yes, you will be able to access. Sorry, I've been distracted by the chat box. It's not really distracted. It's listening to my adult students. Yes, you'll be sent an access to the video of this, so you'll have the full recording, and the PowerPoint will be available on the website as well. So photo, for example, is light. Synth is putting it together, with or together, and thesis is setting, putting, or placing. So that's photosynthesis. Photosynthesis is probably one of my favorite processes. Got so many favorite processes, but that's one of them as well. And teaching students photosynthesis, lucky you guys. All right, so thinking about how we can support our students in developing their scientific writing skills. This can be, I think scientific writing can be tricky, like all writing initially. What's a good tip is really to help them focus in on what is the purpose and the audience, which is really fundamental to every type of writing. So it's the, why am I writing this and who is it for? Yeah, it is difficult. I think it's difficult even as adults whenever I write anything, it's the most difficult, because you think, what's my audience? and how is this going to be helpful? So I'm about to provide you with a framework that should be helpful in supporting you in teaching this writing. So as with any scaffold, and you will all know this as teachers, is that we introduce a scaffold with the hope that one day we'll remove the scaffold, because our students will become so confident and have realized it so well that over time we can remove it. I like that. Examples can help too. Examples are a great idea, and then taking that example point further is bump up walls for examples that show that, say, a different paragraph written in a slightly more accurate way, and then what grade that would achieve in comparison to others. Thank you. That's a really good point. I think examples are crucial. So this is a scientific writing template, and it just has the basic overarching idea. So it gives you an idea. So the beginning ideas, which are what are my questions, methods, what did I do, observations, what did I see, claims, what can I claim, and there'll be different ones for different purposes. Some will involve hypotheses. I like those as well. Evidence, how do I know? Why am I writing these claims? In an evidence-based organisation that I love. How do my ideas compare to others? Fantastic, a question to ask. And then how have my ideas changed? And that will be cyclic. So that's just an example of a template, and you'll be using these types of templates within your classrooms now, and using examples. Excellent. Yeah, that's a great point, and an excellent scaffold for English as second language students as well. And we're always, as teachers, thinking about how we can differentiate to meet all the learning needs of our students, while being mindful too that we don't want to break ourselves in the process. All right, so feedback. How can we think about feedback specific within the context of science? And this is looking at feedback, the overall headline figures from our teaching and learning toolkit. I might also go back and insert the links into here so that you've got them and they link straight out to the toolkit, because I think that would be helpful. Got a low average cost, we've got a good evidence security, and we've got an 8 months worth of impact. And our impact is a translation from a mean weighted effect size. Yeah, that's a good point. I like Amwave. We learned for that last scaffold as well. So as I asked before, I would love to get your thoughts on how you currently define feedback. If there are different categories that you think that we can give feedback to our students. And if you could enter those into the chat box, that would be fantastic. Yeah, I'm with you with the what have I learned. I'll give you a couple of minutes. Verbal, great. And verbal can be very useful and disarming, and it's nice because it's instantaneous. So that can be some of the great positive aspects to verbal feedback. Yes, all right, letting students know what they've done well and how they can improve for next time, very much so. So we want to provide them with feedback on how they've grown since the last time we've talked to them and where to go next. Great, how they can improve for next time. Oh, you guys are going fantastically on the chat box. Yep, improvements or better ways to phrase things. Yep, lovely. And that can be very specific, and specific feedback is helpful. And when I'm talking about feedback, I want you to be aware, because I come from a teaching background, I'm not talking about us increasing marking. I'm actually talking about, my idea is decrease our marking, focus in on maybe slightly different things, but I'm sure most of you are focusing in on these anyway. And then, so less often, less marking for teachers is my drive, because or else it just gets ridiculous. Great verbal, fantastic. Yes. Constructive. Oh, I like this. Constructive, instructive, immediate, and comprehensible. Fantastic. Directed towards metacognitive strategies. Exactly right. Targeted towards something that students can change, and also a high ticket item. And a high ticket item is metacognitive strategies. Self-regulation, definitely. We know that that can be really important. Peer feedback is an excellent way for you to reduce your workload, and also it can be a way to, because sometimes students can provide to students feedback that they might not accept from their teachers, and it's also useful for them to learn as a life skill, isn't it? Peer feedback, we could all learn how to do that better. Yes, asking the right questions so that the students can identify their own error, definitely. And then that's forcing them to do the hard work. So that's great. Written, verbal, body language needs to be regular. Exactly. And it needs to be consistent as well, doesn't it? Because we're creating that culture of trust within our classroom, which is really the tricky work of teaching. Yep. Yep. Positive as activities are being done. Yeah, definitely. Positive reinforcement to the class can be an excellent way to reinforce the behavior you want to see. Yep. Great. Exactly. We can have apps where they've learned where they show us what they've learnt. I've seen with scanning of QR codes, whether they've got it or not, etc., in different classrooms. Formative, very much sure, very useful. Think, pair, share. You guys are on fire tonight. You're just going to run the rest of the webinar for me. Think, pair, share. Excellent. Yep. And then the teachers can jump in and support where needed. And that's great. And that's really thinking about, what I like about support when needed is that's really thinking about, well, you know, how can we help our students to provide quality feedback to each other, and then step away from that. Maybe C3 before me as a strategy as well. No doubt you've heard of that. C3 peers, then come to me, where it will be releasing this week in our implementation guide an example around the implementation of feedback in an Australian school, which go through a lot of these strategies that you're suggesting. Thank you so much. That is just amazing participation, especially at this time of night after you've taught all day. Thank you. All right, so different categories. And what is it? So, as I said, constructive comments, all right? Minimize workload for teachers. Most effective when students know how to respond and are given time to do so. Great, very useful when addressing conceptual change. In fact, that fits perfectly with what I'm talking about just now. As you were saying, peer assessment, why is it useful? Because students will often accept criticism of their work from their peers, which they might not accept from their teachers. And it's very useful to learn how to give constructive feedback to others, and that's something that we can give and help our students with. So here, if we go back to what we covered initially within that quiz, here are the different levels that we can direct feedback to. So we've got the self-evaluation. So well done, you worked really hard this week. We know that this is ineffective. There's a meta-analysis that includes praise within it, Kluger and Denisi, 1996. And what they saw was a much lower effect size than other studies, because ones that included praise were included. We also know from the work of Carol Dweck that that type of praise, which is around that self-evaluation, around the evaluation of the student, isn't helpful in building resilience in our students. And I could go on about that for a while, but I'll try not to. But complex thing, but we're not saying that don't praise it all, just separate it out from providing feedback or associate it with something that's useful within your class, like about choosing the strategy. All right, so at the task level, this is useful. It helps students answer the questions of how can I get this done and how can I make this better. And before we had some feedback in the chat saying that, well, we can ask our students these questions. So these are the types of questions that we can ask them. How can you make sure that you're going to get this task done? How can you make this better? So an example of this is next time you do a calculation like this, try set it out the way I showed you. Process, how can I get better at tasks like this? What does it mean to be good in this subject? Your understanding of Ohm's law is good, but be careful to use the correct units. I think next time I'm going to change that to Avogadro's number somehow, because I just loved Avogadro's number. All right, getting off point, but kind of on point as well. All right, self-regulation. How can I manage myself to learn better? And how can I motivate myself? Examples of this are you happy that you understand photosynthesis now? What could you do to extend your understanding further? So these are very powerful, that type of feedback in those areas. We know that this is the type of feedback that can shift our students' learning to where it needs to go next. And that's really all feedback. Feedback is thinking, my students currently at A, how can I push their learning to B in whatever that is? So what are other ways that we can help our students in providing feedback? By separating the marks out and perhaps not providing them during the term, as some schools have tried to do, because marks we found can demotivate students with lower achievement and then can make students with higher achievement feel a bit complacent. In contrast, comments show both groups of students how they can do better. So for example, you understand about homeostasis, what a lovely sentence, but try and find some examples from plants as well as animals. So great. So they know where to next. And as I've been saying, and I can't say this enough to you, my fellow teachers, is try and make it quality, not quantity. The smaller quantity of richer feedback is likely to do more good than a larger quantity of superficial marking. Plus, any large degree of marking and drafting is just, the workload becomes too difficult and isn't sustainable. And we want to keep you in the profession for as long as we can, forever. All right. So, quality feedback in summary, it's specific, it's accurate, it's clear. Makes connections with prior performance or on the student's success or failure on another part of the task. It's encouraging, helping students to identify things that are hard and require extra attention. So provides guidance to students on how they should respond to their teachers' comments, and you can work with your students to help them further understand where they need to take that feedback, and provides concrete suggestions for improvement. So that's a scaffold for feedback. You know what's delightful? We're running a little bit ahead of schedule, so we've got time for questions, or we can just have an early mark because we've worked all day, really. So up to you guys. If you've got any questions, type them into the box. And those of you that would like to go back to the lives that you had prior to joining us on the webinar, can go back to those as well. I'll just give it, hands are raised, hands raised, what are the hands raised for? Oh, I can't push the mic over to you. So if you type them into the chat box or put them into the question box, there's a Q&A box. So if you type them in there, or type them into Nessa Details No on the NESA details. No need to have those provided to us currently. Thank you for that question. Is there any other questions? We can give you a certificate of participation. Yes, you will get a link to the resources. And great question there. There is a way that you can obtain a copy of everything that's been presented so far. So the webinar will be posted on our webinar site. We'll send you a link with everything within it. So we post our webinar in about a week, the video recording, and also all the resources will be emailed out to you as well as attendees. So great question, and I can give you a nice simple answer. So you can go back, we've got all our webinars from last year as well, so they're always there and you can access them all on the website and you'll get them sent to you. Yes, you will get a link to the resources. I think an early mark's quite nice. So everyone, if there's no more questions, I'll keep an eye on the chat box. I reckon we wrap up and give ourselves an early mark because we've just been spectacularly, you've just participated really well and had excellent input into this session. If you want to find out more about what we do, absolute pleasure. Glad it was helpful. Join our evidence-informed educator network. Great. Subscribe to our newsletter for updates. Absolute pleasure, teachers. Absolute pleasure to be with you tonight. We're on Twitter. I'm on Twitter too. So glad it was helpful because that's what we're here for. So glad. We're on Facebook as well, and any comments and feedback on this session, do provide it, and there'll be a little survey link. It will take you 2 minutes if you would like to, and fine if you don't want to as well. Absolute pleasure to be with you all tonight, and I hope you join us for our next one, which will be on implementation, and we'll be running them throughout the year. So I think we're just going to stop there and call it a night, and I say thank you to you for taking times out of your busy schedules. You're doing the hard work in schools every day, and I just applaud you for coming tonight.